Good morning, my dear students. So now I'm going to determine what natural frequency of the given system. Okay, so already we studied about what are the different method to find the natural frequency. Okay, in the last PPT. Okay, so for what are the different three methods? So first one is we are going to determine the natural frequency by three method. First one is called as what? Equilibrium method. Second one is called as what? That energy method. Third one is what? The relay method. Okay, these three methods we are going to use to find the natural frequency of the particular system. Okay, why we need to study this natural frequency of the particular system? To avoid the resonance in the machine element. Okay, so to for that we are going to determine the natural frequency. Okay, so natural frequency what? Omega n is equal to square root of k by m. Okay, that you remember. Okay, so the first problem they may ask like this: determine the natural frequency of the simple pendulum. Okay, so here the simple pendulum system is given. Okay, so when they are considering two cases. First one is so neglecting the mass of the rod. Second one is considering the mass of the rod. Okay, taking these two to find the natural frequency. Okay, let us understand the first. Okay, so just to draw the simple pendulum, that is the first diagram. Okay, one end is fixed and it is a moving. Okay, that is called as mass m, that is called as a bob. Okay, one is string and angle from the axis to the pendulum is called as a theta, denoted by theta. Okay, so just again come to the figure P. Okay, so here the what are the forces acting on that? Okay, so one is along that light, that is what, left hand direction, right hand direction. One is gravitational force. Okay, T, and one more angle is mg cos theta. Okay, so weight of the gravitational that force also called this. Okay, so these are the forces created, that is generated particular system while moving the simple pendulum. Okay, so neglecting the mass of the rod. Okay, first case, let us m is the mass of the bob. Okay, m is the mass of the bob, l is the length of the rod, I naught is equal to moment of inertia about the o. I naught is equal to moment of inertia about the o is equal to what? Ml square. Okay, so I will repeat here. In a simple pendulum, when it is rotated in a swinging around the axis, there is a forces will be generated. One is a what? Weight due to gravity, one is the tension. And okay, so these are the two forces acting on that particular element. Okay, I shown in the diagram also, in the last third diagram. Okay, so mg sin theta, mg cos theta, and tension force colors make a triangle one. Okay, by according to the Newton method. Okay, according to the Newton method, the Newton's second law of the motion in the form of torque equation is given by what? Acceleration torque is equal to restoring force. Okay, so here the formula is equal to what? I naught theta double dot is equal to minus mg sin theta into L. Okay, but we know that sin theta is very neglect. So I naught, that is moment of inertia, I naught theta dot double dot is equal to minus mg theta into L. Okay, so I naught is equal to what? Ml square theta double dot plus mg L theta is equal to 0. Okay, so again divided by that ml square, we are going to get what? Theta double dot plus j by L theta is equal to 0. So it is the equation of motion. Okay, give equation number 1. Again theta double dot j by L is equal to what? Omega n square theta equal to 0. This is the angular frequency, that is angular rotation. Give equation number 2. Okay, mass is rotated about the fixed point in a torque method. Okay, so I shown in the diagram also. Okay, that is in swinging around the what, 180 degree. Now compare the equation 1 and 2. Omega n is equal to what? Square root of j by L. Okay, therefore the natural frequency, once you know the that what omega n value, natural frequency is equal to what? F of n is equal to 1 by 2 pi omega n. Okay, therefore the natural frequency f of n is equal to 1 by 2 pi square root of j by L hertz. Okay, so this is about the natural frequency when neglecting the mass of the bob of a simple pendulum. Okay, so so this is another method that you don't require. So second method is what? Considering the mass of the rod. Okay, so when if you consider the mass, okay, so let mr be the mass of the rod and it is acted through a center of the rod, that is midpoint of the in both the side, that is I shown in the diagram also. Okay, considering the mass means, let us assume there are two different forces will be acted. Okay, weight due to mass, weight due to considering the weight mass. Okay, mg cos theta, mg sin theta, and the length L. Okay, so total length is L, half of that means L by 2, L by 2. Okay, so theta is equal to what? The swinging to the x-axis of the angle is considered as theta. Okay, according to the Newton's second law of motion, in the form of torque equation, we are going to what? Restoring force is equal to I naught theta double dot. Okay, so I naught is equal to what? Ml square plus half of, that is a 1/3 to 1 by 3 mr into L square theta double dot. Okay, into L the theta double dot is equal to restoring force. What? There are two forces will be there. One is half and another is original mass. Okay, minus mg sin theta into L minus mr g sin theta L by 2. Okay, but theta is equal to very small, that is sin theta. So therefore minus mg l theta minus m into r g l theta divided by 2. Okay, so here again resimplify that, l get going to cancel. So here m plus 1 by 3 mr l in theta double dot plus minus l theta g m plus mr divided by 2. Okay, so again just to take the common here, m plus mr by 3 l into theta double dot is equal to minus m plus mr by 2 theta into g. Okay, so again just the simplification will be there. Okay, m plus 1 by 3 mr, okay, into l theta double dot plus m plus 1 by 2 m into r, okay, theta g is equal to 0. Okay, divide by l, we are going to get what, m into mr by 3 theta double dot plus m plus mr by 2 theta by l into theta is equal to 0. Okay, again divide m plus m by mr into 3, but okay, we want in terms of theta double dot equation. Okay, therefore theta double dot is equal to what, theta double dot plus m plus mr by 2 whole divided by m plus mr by 3 into g by l theta is equal to 0. Okay, so therefore this is what the natural frequency. Okay, so natural frequency is equal to what, omega n is equal to square root of m plus mr by 2 divided by m plus mr by 2 into g by l radius per second. So this is about the natural frequency, that is then what natural angular, that is what natural frequency. Okay, so but we know that the natural frequency what, f of n is equal to omega n divided by 2 pi, that is angular frequency, this is natural frequency. Okay, f of n is equal to 1 by 2 square root of m plus mr by 2 divided by m plus mr by 2 into g into l. Okay, so this is about the natural frequency when considering the mass of the simple pendulum. Okay, so this is about the, this is also very important problem. So when considering the negative the mass, when is considering the mass. Okay, that is the first problem. Okay, now second problem, let us understand this. Okay, determine the natural frequency of a compound pendulum, that is a physical pendulum. Okay, so how we are going to derive this. Okay, so let us assume consider a rigid body having an angular oscillation with a small amplitude under the action of gravitational force and suspended vertically is called as a compound pendulum. Okay, so compound pendulum I shown here. Okay, so look at the just to see the diagram. So just one fix upon that, there is a rigid body is oscillating in a angular position. Okay, with a small amplitude. Okay, so here that is the total length is l and the angle rotation is called as theta. Again here there are three forces acting, mg sin theta, mg cos theta, one is weight. Okay, so from that you are going to derive the natural frequency. Okay, let the pendulum is displaced through a mass angle theta from the vertical mean equilibrium position. So these are the notations we are going to use. Let w is the weight of the body is equal to mg, k is the radius of the gyration, not a stiffness here, radius of the gyration of the body, l is the distance of the point from the suspension from the g, I is the moment of inertia of a body at point p, I, that formula is given by what, mk square plus ml square. Okay, so according to the Newton's second law, this method we are going to solving by Newton method, energy method. Okay, that is equilibrium method. Okay, so I naught theta double dot is equal to sum of couple about point p. Okay, I theta double dot is equal to minus mg sin theta into l. Okay, sin theta is very small, I theta double dot is equal to what, minus mg theta l. Okay, so radius of that is I is equal to what, mk square plus l square theta is equal to what, minus mg theta into l. Okay, so theta double dot is equal to m square plus l square is plus that you take in this side direction plus mg l theta is equal to 0. Okay, divide theta, okay, whole divided theta, we are going to get what, theta double dot plus m get going to get cancel, gl theta whole divided by k square plus l square is equal to 0. Okay, so after that you are going to get what, theta double dot plus g of l divided by k square l square in theta is equal to 0. Equation number 1. Okay, we know that theta double dot plus omega n square theta is equal to 2 is similar to that equation number 2. So compare equation 1 and 2, you are going to get what, omega n square is equal to g l divided by k square plus l square. Okay, so omega n is equal to what, square root of g l by k square plus l square radian per second. Okay, so once you calculate the natural frequency, that is angular frequency, so you are going to get what, natural frequency f of n. Omega n is angular frequency, f of n is equal to natural frequency, f of n is equal to 1 by 2 pi omega n. Okay, where omega n is there, just to substitute their values, f of n is equal to 1 by 2 square root of gl by k square l square. It is in hertz. Okay, so this is about the natural frequency of a compound pendulum. Okay, so these two problems are very important for the point of examination in the part section 2. Okay, so they may ask whether simple pendulum or compound pendulum, and another method that is simple, that is spring mass damper system. Okay, so all methods are very important in for the point of examination. Okay, simple pendulum, compound pendulum, just nothing but just use the energy method. According to that restoring force this you apply, I naught theta is equal to restoring force. What are the forces acting on that? Just to write it here and make it equal and simplify, and you bring that form in the this form. Okay, that is what theta double dot form. Okay, so once you get that omega n is equal to compare, you are going to get the final equation. Okay, I hope you understand this simple pendulum and compound pendulum of a natural frequency. Okay, so we derived this. Okay, I hope you understand this. Thank you.